Okay, we're going to do a bunch of problems here that are problems based on transformations, just so you can hear me work through some. And I brought up the formula sheet for Math 140 here so that you can see what's on the formula sheet and see how the formulas help you write this. Okay, so number 1 says the graph of y equals the absolute value of x plus 4 can be obtained from y equals absolute value of x by, that should say which transformation. So here we're adding something to the end, right? The thing that's different is this plus 4. So if we look over on the formula sheet, where are we adding something to the end? And here it's a vertical translation. Now you do have to remember, okay, well, when we add something, does that move it up or down? Well, adding something vertical to the end moves it up. So here we'd say this is a vertical translation up by 4. Okay. So number 2 says the graph of y equals 5x squared minus 3 can be obtained by y equals x squared by which transformations? So notice we're multiplying the x squared by 5 and then we're subtracting 3. Now multiplying on the outside, since we don't have parentheses, multiplying on the outside would be like the vertical stretch or shrink. Remember, vertically when we multiply it by a number bigger than 1, that stretches it by that much. So we'd say a vertical stretch by a factor of 5. And then the subtracting 3, well, subtracting 3 from the end, that's our vertical translation. So we'd say and down 3. Okay. So number 3 says the graph of g of x equals negative 1 over x plus 3 can be obtained from g of x equals 1 over x by which transformations? Now there's a couple of things going on. We've actually multiplied the whole function by a negative 1, and where there was an x, we've now plugged in x plus 3. So since that's not a plus 3 at the end, it's actually where the x is in the function. Think of that like inside the parentheses. Now multiplying the whole thing by a negative 1, that would be our reflection across the x-axis. The negative 1 is on the outside. So first we'll say reflect across x-axis. And putting the plus 3 in where the x is, well, that's our horizontal translation. And remember, horizontal sometimes seems backwards. Adding means we've actually moved it left. So we've, I guess instead of moved, the better word is translate left 3. Okay. So 4 says the graph of h of x equals x squared, or sorry, x minus 2, that whole thing squared, plus 4, can be obtained from h of x equals x squared by which transformations? Now we're subtracting 2 inside the parentheses. So subtracting, adding and subtracting always means you're moving up, down, left, or right. When it's inside the parentheses, we're doing it horizontal. Remember, subtracting inside the parentheses means you're going right. So we're translating right by 2. Now, the 4 we're adding to the very end. So that means we're going up 4. So now we're going to kind of do the opposite. We're going to start out with our parent function, and it's going to tell us what to do to it and how, we have to find the equation. So 5 says, write an equation for a function that is in the shape of y equals x cubed, but is shifted 5 units to the right and up 4 units. Okay, now 5 units to the right, left and right, means we're going to do it inside where the x is. So here we'll call this our new y, and inside where the x is, if we want to shift it right 5 units, remember right, we need to subtract. So x minus 5 cubed, that will shift it right 5 units. Now we want to move it up 4. Well, moving up or down, we add or subtract to the very end of the function. So moving up 4, we want to do plus 4. Okay. Number 6 says, write an equation for a function that is in the shape of y equals the square root of x, but is upside down and shifted left by 3 units. Now, upside down is the same as reflect across, oops, sorry about that, the x-axis. To reflect across the x-axis, remember that's kind of a vertical thing, we multiply the whole function, the outside, by -1. So we're going to have a negative square root. Now we want to shift it left by 3 units, so that's something we're going to do in where the x is, inside the square root here. And shifting left, we're going to add 3. Okay. Number 7 says, write an equation for a function that is in the shape of y equals the absolute value of x, but it is stretched horizontally by a factor of 2 and shifted down 4 units. Now, stretched horizontally by a factor of 2 means we're going to have to multiply on the inside by 1/2, because remember, stretching horizontally, you have to do something less than 1. So the stretching horizontally will actually be a 1/2 x inside the absolute value, and shifting it down 4 units, we're going to subtract 4. Okay, we've got just 2 more problems, and these are a little different, so just for you to see them. So 8 says the point 10, 12 is on the graph y equals f of x. Find a point on the graph y equals g of x, where g of x is equal to 3 times f of x. Now remember, f of x is the same as your y. So we're saying g of x, you're multiplying 3 times all of your y values. So our x here is actually going to stay the same, and we're going to do 3 times the y value, so 3 times 12. So the point we get is 10 and 36. Okay, so here, when we're just doing something to the f of x, we're actually just changing our y value. So number 9 will be very similar. It says the point -14, 6 is on the graph y equals f of x. Find a point on the graph y equals g of x, where g of x is f of x plus 4. So we're saying our new y is going to be our old y plus 4. So we're going to leave the x alone here, and we're going to add 4 to this y. So 10. Okay, so these were some examples. Really knowing what the rules mean helps, and then it takes a lot of practice to get these down.